Hello and welcome to Math Matters with Miss Jen. I am very excited to talk to you today about how to think about dividing by a fraction. Here's an example down here, and if you're like many young mathematicians, that is a slightly intimidating problem. So I'm going to teach you how to think about how to divide by a fraction. And to begin, we're going to talk about how to think about dividing by any number, even a whole number. Let's take a look at this problem here. We're going to think of it in two different ways, so we'll focus here to begin. 10 divided by 2. Now, oftentimes what you probably do when you think about 10 divided by 2 and you look at this picture is we tend to think that 2 is the number of groups. So we think we've got 10 circles all together, let's divide them up into 2 groups, and then our answer is going to be the number that's in each group. So here's an easy way to divide it into 2 groups straight down the middle. So there's one group and here's the second group. And we have 5 circles in each group, so 5 is our answer. 10 divided by 2 is 5. But how about thinking about it like this, which also works and is going to be much more helpful for when dealing with fractions. Here we have 10 circles, and when we divide it by 2, we're going to think about 2 as being the number in each group. And what we're trying to solve for is the number of groups, or the number of 2's. So it's kind of like asking ourselves the question, how many 2's are in 10? So I'm going to circle some groups. I don't know how many groups I'll end up circling, but I know I want 2 in each group. So here's a 2. That's one 2. Here's a second 2, a third 2, fourth 2, and fifth 2's. There are 5 2's in 10 altogether, and indeed 5 is our answer. Let's apply the same concept, this kind of way of thinking about it. How many 2's are in 10 is what we're going to apply for the rest of this lesson. All right, let's now think about 8 divided by 3. So the question we're going to be asking ourselves is, how many 3's are in 8? I have 8 circles here, and I'm going to be circling groups of 3. So here's 3 here. That's one 3. Here's a second 3 right here. And ooh, I don't really have a third 3. I have 2 3's and then a little bit more. So I have 2 groups of 3, and then I'm looking for 3 circles, but I only see 2. So I only have 2 out of the 3 that I'm looking for. So my answer is 2 2/3, which you could also make improper if you wanted, which would be 8/3. So there we go. That's pretty straightforward. These are still whole numbers, but our answer did end up being a fraction. Now let's look at 8 divided by 1/3, for example. So our question here would be, how many 1/3's are in 8? Can we circle our 1/3's? First of all, let's split our wholes, each one of these is a whole, into thirds. So I'm just going to kind of make peace signs for all these. I'm splitting them into thirds because I'm looking for thirds. That's what my denominator shows me there. So how many thirds are in 8? Well, I can see 1/3 here, that's 1. Here's a second one and a third one. 4, 5, 6 thirds, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 21, 24. There were 24 thirds in 8. Now the method you're probably familiar with sometimes has a cutesy thing called keep, change, flip, where you keep the first number the same, you change division to multiplication, and you flip 1/3 into 3/1. Now, this is also known as multiplying by the reciprocal. So instead of dividing by 1/3, we're going to multiply by the reciprocal of 1/3, where the numerator and the denominator switch places. This method here will always work. But do any of you actually understand why it works? If you do, feel free to comment below. But I would bet most of us are very hard pressed to explain why we can just multiply by the reciprocal and why that actually works. So this model that I'm teaching you here, this method of solving, is called, I'm calling it by modeling, so drawing a model to see. And this method here is called multiplying by the reciprocal. Let's go ahead and finish it out and see if we get the same answer. When we're multiplying like this, oftentimes we like to put 8 over 1. 8 is the same as 8 over 1. We multiply our numerators to get 24. We multiply our denominators. 1 times 1 is 1. And our final answer is also 24. Same answer, different method. Let's go ahead and look at another problem. I'm actually going to introduce also a third method, which I think is very cool and only just yesterday understood on the deepest level that I understand it today. So I'm very excited to share. Here's a problem. 2.5 divided by 5/8. We'll do method 2 second. That's probably what you might think to jump to. But let's start with our new method, the first method of drawing a model so we can see. So we're going to draw 2.5. And the question we want to ask ourselves, oh, I wrote it over here already, is how many 5/8 are in 2.5? So there's 2.5. How many 5/8 are in there? Well, I'm going to want to divide out, separate these into eighths because I want to know about eighths. So there's quarters and there's eighths. There's quarters, eighths. And then we can kind of do the same thing here, except we only have 4 of the eighths here. All right, so now, how many 5/8 are in 2.5? I'm going to take my pen and I'm going to circle, or maybe in this case, color in how many 5/8 I see. So here's 1, 2, 3, 4, 5/8. There's one group of 5/8 right in there. Let me circle a second group of 5/8. 1, 2, 3, 4, 5. There's another group of 5 right in there. 2 groups so far. Find a third group. 1, 2, 3, 4, 5. There's a third group. Now notice I still have that little guy down there. So here's 1, 2, 3, 4, 5. Wow, I ended up getting exactly a whole number. I have 1, 2, 3, 4 groups of 5/8. Pretty cool, huh? Let's go ahead and prove to ourselves that that works by also doing the second method, multiplying by the reciprocal. And that method, I would keep the first fraction the same. However, I actually do want to rewrite it as an improper fraction. So 2.5 is the same as 5/2. Then I'm going to change my division to multiplication, and I'm going to multiply by the reciprocal. So my numerator and my denominator switch places. 5/8 turns to 8/5. Now in this case, I can go ahead and just multiply straight across, but whenever we're multiplying by fractions, it's really nice to cross-cancel first to reduce ahead of time. So my 5 divided by 5 is just going to be 1, and that's going to disappear. And here, let's simplify these by 2. I'm going to divide this by 2 and divide this by 2. These just got 1s. So this is really turned into 1 times 4 over 1. Which is, of course, just 4. So I got the same answer. Finally, let's talk about dividing across, which I now understand to be an excellent method that's also kind of related to this question we've asked ourselves up here. So let's solve it the third way. What I'm asking myself here is how many 5/8 are in 2.5, but remember, it's nice to kind of talk about 2.5 not as a mixed number and as an improper fraction instead. So we're asking how many 5/8 are in 5/2, right? That's pretty much the problem we have here. I'm just rewriting the first fraction. So let's go ahead and get common denominators just so we can know what we're really talking about here. I want these to be eighths. So let's multiply by 4 over 4. We're allowed to do that. 4 over 4 is just 1. We can always multiply by 1. It doesn't actually change the value of the fraction. So now I have 20/8 divided by 5/8. So our question now is how many 5/8 are in 20/8? So can you imagine having 20/8 and then finding out how many 5/8 are in there? Really, that's the same thing as just saying how many 5s are in 20, and we already know the answer to that, right? But we're going to do a divide across method here. 20 divided by 5 is 4, and 8 divided by 8 is 1, and 4 over 1 is 4. We could have divided across back up here when we had 5 halves divided by 5/8. It just would have been a little funkier. Let's see what we would have got. 5 divided by 5 is our numerator, which is 1. And 2 divided by 8 would be in our denominator. 2 divided by 8 is just a quarter, right? It's 1/4. We don't like having fractions of fractions, so instead of having this be a quarter, I'd really like it to just be 1. We really like that. So what do I have to multiply this by to get this to be 1? Well, 4. So then I have to also multiply the numerator by 4. And do you see, it's really, we did that up front over here, but here we're going to have to do it on the back end. 1/4 times 4 is 1, and 1 times 4 is 4, giving my same final answer. So all of these different methods work. The main point I'm trying to drive home is that although you've memorized this one, you probably don't understand why it works. I barely understand why it works myself. But this modeling method is really wonderful to visualize it. And then this method is also kind of neat in how it works. Let's look at a couple more examples. Eight and a half divided by 1 1/4 is what? Well, let's rewrite 8 1/2 as an improper fraction instead of a mixed number. So I've done that here. That's the same thing. And we're writing 1 1/4 as an improper fraction. So we're kind of asking ourselves, how many 5/4 are in 17 halves? So we have 8 1/2 here. Let's go ahead and split them up so we can see that what we really have is 17 halves. I'm going to prove to you that 8 1/2 really is the same thing as 17 halves. Do you see? 1 2 halves, 3 4 5 6 7 8 9 10 11 12 13 14 15 16, 17 halves. So these really are the same thing. And actually, 17 halves we could also rewrite as quarters, couldn't we? If we multiply by 2 over 2, we get 34 quarters. So can I prove to you that what we have here really is 34 quarters? There's 4 quarters, 8, 12, 16, 20, 24 quarters, 25, 26, 28 quarters, 28, 31, 32 quarters, 33, 34 quarters. Awesome. So now, how many 5/4 are in this, what we got here? Well, let's take a look. 1 2 3 4, there's 5/4 there. That's one group. 1 2 3 4 5 quarters there. That's a second group in there. I like to use different colors. 1 2 3 4 5, there's a third group in there. Let's see, 1 2 3 4 5, there's a fourth group. There's a fifth group of 5/4 in there. 1 2 3 4 5, there's a sixth group of 5/4. So my answer is going to be something about 6, but now I'm looking for 5/4 and I only found 4. So I only have 4 out of the 5 pieces that I'm looking for. So this is going to be my final answer. Pretty cool. Let's try multiplying by the reciprocal and see if we can agree with that. So let's go ahead and take our original question and change the division to multiplication and write the reciprocal. All right. In this case, before I go ahead and multiply across, I'm going to cross cancel to reduce first. This divided by 2 is 1. This divided by 2 is 2. And my numerator is 17 times 2 is 34. My denominator, 1 times 5, is 5. Now this is improper if we want to write it as a mixed number. I know that 35 is 6, but I have 34 5s, so I have 4 extra 5s. Here's how we write that as a mixed number. And indeed, it's the same answer as before. This was method 1. Here was method 2. How about we try method 3 now of dividing across? And in this situation, for method 3, we're going to start with our first number here, which remember we can rewrite that as 17 halves. And we're going to divide it by, let's write it as improper, 5/4. So for this method, we can just go ahead and do 17 divided by 5, although this method might not work quite as well, huh? And we're going to do 2 divided by 4, which is a half. This is starting to look pretty ugly. What if instead we rewrote this as fourths? So we, in other words, multiplied by 2/2. Sometimes you'll try things in math and you'll get something that's ugly, so you'll just want to try again. Remember we said the 17 halves is the same as 34 quarters, so let's rewrite this as 34 quarters. So we want to know how many 5 quarters are in 34 quarters. And this becomes a lot easier to see. 4 divided by 4 is 1. 34 divided by 5 is 34/5. And anything over 1, you just don't even really need to write the 1. It's just itself. We got 34/5. But just like before, we can rewrite 34/5 as 6 4/5. And we get our same final answer. I really like thinking of this method as thinking how many 5/4 are in 34/4. And that's really the same thing as asking yourself how many 5s are in 34, which gives us the fraction that we're looking for. I'm going to do one final example, but you're welcome to pause at that point if you feel like you understand. I really like this final example though, because it's going to be another example where maybe some of our methods work better than some of the other methods. 4½ divided by 1/3 equals what? So the question is, how many 1/3 are in 4½? I'm going to go ahead and draw 4½. 4½. And since I want to know how many thirds are in there, I'm going to divide this into thirds. I'm actually going to change the question. Let's ask ourselves how many 2/3 are in 4½. I like that a little better. Now it's hard to divide this into thirds, so I'm going to maybe just do that line here. This is the third, and then this would be, what, a 1/6 in there? That makes up the half. Alright, so let's circle our groups of 2/3. Here's one group of 2/3. I'm going to color it. Here's a second group of 2/3 in green. Here's a third group. A fourth group. Fifth group. A sixth group right here. So my answer is going to be 6 and something, but I don't have 2/3 here. I have 1/3 and half of a third. Let me try writing it like this. I have 1½ thirds, but what I'm really looking for is 2/3, right? So I only have 1½ out of the 2 that I'm looking for. Again, this is a little bit messy, so let's just rewrite it. I want to get rid of this half, so I'm going to multiply just this part here by 2 so I can get rid of that half. So I'll multiply it by 2/2. 1½ times 2 is 3. And 2 times 2 is 4. So even in a situation here where it looks like this method might not be the best, this modeling method, because we end up getting this weird part that's going on here, even in this case it works. But let's say you didn't really know how to do this last part here and you just knew it was 6 and something. Maybe you'd estimate about 6 groups and then maybe about a half a group, about 6½. That'd still be a pretty nice estimate. Let's compare it to method 2, multiplying by the reciprocal. So here I'm going to write 4½ as a mixed number. Sorry, it is mixed. I'm going to write it as improper. I'm going to multiply by the reciprocal of 2/3. And when I go ahead and multiply across, there's nothing I can reduce or cross cancel first. So 9 times 3 is 18. 2 times 2 is 4. And 16/4. Uh-oh. Let's see if I made a mistake. 9 times 3 is not 18. 9 times 3 is 27. So I have 27/4. I was starting to get an answer that was different than this answer here, so I knew something was wrong. So let's see, 24/4 is 6. But I have 25, 26, 27. I have 3 more fourths. So that's how I think about making an improper fraction into a mixed fraction again, mixed number. Same answer using the first two methods. Lastly, let's try method number 3, which is dividing across. We'll do 9/2, which is this first number here, divided by 2/3. So we're kind of asking ourselves how many 2/3 are in 9/2. But for this method, it's a lot nicer to rewrite it with common denominators. We really like having common denominators. So let's multiply that by 3/3 and this by 2/2 because our least common multiple is 6. So we're going to get that as our common denominator. And here we'll have 27/6. And here we'll have 4/6. All right. And we are actually dividing. So now we're going to use method 3 of dividing across. And we're going to do 27 divided by 4. And then we're going to do 6 divided by 6 as one way to think of it. Anything over 1 is just itself. We really just have 27 divided by 4, which is 6 3/4. The way I like thinking about this dividing across method best is at this stage right here. How many 4/6 are in 27/6? We're really asking ourselves how many 4s are in 27. How many 4s are in 27? And the answer is 6 3/4. So I'm curious which method you like the best. Perhaps even after trying out all 3, you'll decide you really prefer just multiplying by the reciprocal. It does always work if you don't make a mistake. But hopefully now, after expanding your brain by exploring different methods, you will be able to see, at least very much believe that this works, and you'll have another sense of how to think about it. Again, math isn't just about finding the right answer. If it was, we could have stopped the first time we got the answer. It's about growing our brains, thinking about why it makes sense, and having a strong number sense. So I hope you enjoyed.